Drug is available in 20 ml bottles containing 75 milligrams per 2 mils. So let's just understand this information. If the drug is available, it means this is what we have, this is what is in stock, and the concentration, the ratio is 75 milligrams per 2 mils. The 20 ml bottles are important because that's the size of the bottle you will look for, but you won't need that for this calculation because the concentration has been given to us explicitly here. Let's read on. 4 mils is given. If 4 mils is given, how many milligrams of the drug is this? So given, this has been given to the patient, so this is originally what we wanted to give to the patient. So this problem reads in a slightly different way. Instead of first giving us what the prescription is, what has been prescribed by the doctor, what the patient needs to receive, what the patient will receive, will be given, we were given the concentration of the drug. It's absolutely no problem, so long as we can identify the ratio here, the two quantities. This is always going to be our have, and they are in a ratio, and the third quantity is in mils, which will match one of those. So it is again a box method type question. So we draw the box and we put in the have. Always start with that have. So 75 milligrams per 2 mils. Units in every time. So that information is in. The only piece of information we have left is the 4 mils, and those 4 mils are matching with one of these two, top or bottom. This time it will have to sit on the bottom because we are actually trying to match the milliliters. We want to actually find how many milligrams of the drug that is. So the question mark this time is sitting on the top. The box works exactly in the same way. The only difference is the two diagonals. We have been using this diagonal here as our main diagonal, but this time it cannot be because we don't know what that question mark is, so there's no chance we can multiply 2 by something we don't know what it is. So we are going to use the diagonal coming here from the left. Two quantities in the diagonal, that's what we call the main diagonal, and multiply those quantities. So let's write the equation: 75 milligrams multiplied by 4, and the third quantity divides those two. Equation written all at once, all elements, so then we can only worry about the calculation and we don't need to check back if we have forgotten anything. So we could simply go to the calculator, multiply 75 by 4 and divide by 2, and you get a final answer. But how about we do some simplifying here? It's very tempting because 4 and 2 are really easy to simplify. We can divide both by 2. So instead of crossing zeros, this time we are dividing by 2. So on the top we still have the 75, and then 4 divided by 2 is 2, and 2 divided by 2 is 1. And now at this stage, of course, we then just multiply 75 multiplied by 2. We can do that in our heads. 75 is the same as 70 and 5. If we are multiplying by 2, multiply each one of these two parts by 2. 2 70s, 140. 2 5s, 10. So what do we have in total? 150. If you didn't know that straight away in your head. So 150 divided by 1, which is exactly 150. Now, what does the question mark tell us? that we need to match the units with milligrams. And now we read the question again to see if we have answered. How many milligrams of the drug is this? 150 milligrams. If we wanted, we could also check by looking at the proportions. 2 mils went up to 4 mils. It doubled, so we multiplied by 2. 2 times 2 would be 4. So the 75 would need to keep the same proportion. If we timed by 2, we would get the answer. And 2 times 75, as we know, is 150 milligrams.